Hello everyone, it's a wonderful time once again with you. My name is Victor Dugomoya and we are still looking at probability as an aspect of mathematics. Probability as an aspect of mathematics. So we are still doing a demonstration of selection with and without replacement. You see that anytime we are talking about selection with and without replacement, sometimes it can cause some confusion. It can make some students to some sometimes we understand what the concept is all about, sometimes we may not be able to understand what the concept is all about. So I want to use this opportunity to do a little practical demonstration of selection uh, without replacement and with replacement. Do we get that? Selection without replacement and selection with replacement. So here with me, I'm going to be biased. Here with me uh, in this box I have here. If you look at this now, assuming I have here a question that says a box. I have a question that says box. A box contains what I have here: 5 yellow balls, and 4 blue balls, and 3 red balls. Okay, so and the question is two balls are selected from the box one at a time. Okay, so one at a time. Maybe the question now says A, obtain the probability that both maybe both say are red, both are red. These both are red. I'm going to explain it in two ways at once. I'm going to explain it as it has to do with selection without replacement and selection here with replacement, so that we can be able to understand the difference between the two. Okay, now I've shown us the number of balls here, that we have 3 red balls here, 5 yellow balls, and 4 blue balls in this box. Now assuming I want to select 2 balls here, let me take for instance the first one. Let me take without replacement. I want to select 2 balls here without replacement. You realize that if I pick the first ball, this is a red ball. I want to demonstrate the probability that both are red. You see, if I pick the first ball, this is red ball, it's a red ball. What is the probability of this selection? It will be number of red balls divided by the total sample space. So you realize here that what I'm going to obtain is, so I am calculating this P of both are red. That is, the first selection is red and the second selection is also red. But I want to demonstrate this in two ways in such a way that I'm looking at, let's say, I without replacement, and I want to also demonstrate it I with replacement. Now look at the first selection here is red, so probability of red in that selection which is 3 over the sample space, which we have as 12. Because if you check 3 plus 5 plus 4, 8 plus 4, that will give you 12. 12 balls. Okay. So if you check, this is the first selection being read. Now, this first selection, what we mean by without replacement is that I have taken this and it is a red ball. I am not going to return it inside this box. That is without replacement. I'll keep it outside. Now, the probability of that selection is 3 over 12. Now, I am going to take another selection. You know I'm biased here. Yes, because I want to actually demonstrate with replacement and without replacement. I'm not discussing biasedness or so. Okay. Because ordinarily I'm supposed to close my eyes and shake these and randomly select. But that is not what I'm discussing now. What I'm discussing now is demonstrating with replacement and without replacement so that you can understand the difference between the two. So in the case this selection without replacement, I have taken one ball and the probability that ball is red and the probability is 3 over 12. Now I didn't replace it. Look at it. I didn't replace it. I want to ask a question. What is the number of balls that are left here? You know that it is 11 balls. Do you see now? The sample space is now 11. And what number of red balls is left here now? You see the number of red balls that are left here now. There are 2 in number. You can see there are 2 in number. So if I am taking the second ball and it happens to be red, look at I pick the second ball and it happens to be red. The probability of this selection now will be 2 over 11. 2 over 11. I'm sure I have been able to explain to us what it means without what that concept without replacement means with this now. So I am going to have the probability of first red 3 over 12 times, because they are independent, times 2 over 11. This is now going to do, maybe this takes care of itself here, care of this 6, and then this cancel this 2, and we have 2 times 11, which is 1 over 22. So this is the probability of selection without replacement, and the 2 are red. I hope that is clearly demonstrated. Now, assuming I am still demonstrating this now, and the demonstration is with replacement. So we are still talking about P of first red and second is red, but this case with replacement, you will see that that first selection I made, let me return 2 of them inside here. The first selection I made is this, and the probability is 3 over 12. 3 over 12 times, look at it now, I am replacing. I replace it. Do you realize now that the sample space is still 12 and the number of red balls in this box is still 3? So if I am to take probability of selecting 2 balls being red and with replacement, so it will be first selection being 3 over 12 times the second selection, which is still 3 over 12. I'm sure that this demonstration will clearly help us to understand without replacement and with replacement. You see here that this will obviously be 1 over 4 times 1 over 4, which is 1 over 16. All right, so this is a typical way of explaining a probability of selecting 2 balls with replacement and without replacement. Remember, we have done several classes in this area of probability, and we still have more because later we are still going to also touch um, binomial expansion, and then we are still also going to look at probability of special cases and then some other areas again we still have to delve into. So that once you are with us and you're studying with us, you have a complete, if not complete, a reasonable knowledge of what A level probability classes is all about. I'm trusting God that this class must have added a little knowledge to the one you have already. And if that is the case, you can give us a handshake by clicking on the subscription button and the like button and share our video to your friends and relatives out there. Thank you so much for being there.